Hello everyone, I'm Yusuf Erdem Necar.
And I am Mehmet Emre Akbulut.
Today we will be presenting our graduation project called Social Network Analysis on Research, or SONAR for short. Our aim is to design an analysis tool that allows researchers to perform social network analysis on research networks that are comprised of articles, authors, and the relationships between them in order to uncover quantifiable information in the form of graph metrics. So why do we want to do this? There are several reasons, such as helping researchers guide their scientific effort towards better use of resources, or inferring comparative results between different fields or subfields of research, better representing the importance of certain aspects of research, such as different research fields or research groups, or discovering key researchers and articles for the purposes of networking. Our main approach in the design of the project was to divide the project into three main components, which are described with what they do. These are search and select, graph, and analysis. And in terms of architecture, we have a core application that provides an API that allows users to search for articles or authors through the Semantic Scholar Academic Graph API, create graphs from these entities selected, and store these graphs in the graph database. And we have an analysis component that analyzes the graphs stored in the graph database and calculates graph metrics. And finally, we have a web application user interface. Now, Emre will talk about our results.
We have implemented a project that enables users to do following actions. They can list articles related to a specific keywords with the search engine. They can select papers and apply filters on them. They can also extend articles by some options. They can create graphs and analyze them, also show the results with respect to time. We have calculated the PageRank scores of the nodes in a subgraph of co-authorship subgraph of toxoplasma and mitochondria research graph. It's clear that the nodes with higher PageRank scores are important people. But when we plot the authors with respect to number of papers published, we saw some authors with small numbers of papers published, but relatively high number of with relatively higher PageRank scores. When we analyze their PageRank scores with respect to time, we again see similar results. However, when we investigate the delta PageRank score versus time, we saw that they both have a large number of peaks, but the peaks of Lena Pernas are more drastic than the Yana, which might indicate that Lena gaining popularity faster compared to Yana. Now, Yusuf explained the challenges we faced.
Thank you. There are three main challenges that we faced. The first one was the scope of the project. There were several big components of the project, such as implementing the core API, and also on top of that, implementing a user interface. Also on the side, learning about graph algorithms and using graph databases. And also we have done research about bringing ontologies or other graph structured knowledge representations in our research graphs together. The second challenge we have faced was ensuring the consistency of the data that we gather from Semantic Scholar Academic Graph API. And the third challenge was the setting up and configuring the right environment and setting up the right machines for supporting all of what we do. Thank you for listening. Here are our references, and see you.